Separate and solve the ODE if possible. So this one's a little bit different. There's a trick in order to get this to work, and it's really the only one that they can give you. I think sometimes trig functions that you can collapse or split up can sometimes help you make it a separable equation. But this one, there's a little trick that's not obvious. So here, right, we're going to split the y prime into dy dx dn. In this one, you can actually factor this. So what you can factor this into is x plus 1 and y minus 1. All right, so you can kind of see that here. We get the x times the y. That's going to give us x times y. We have the positive 1 times the y. That gives us the positive y. We have the x times the negative 1. That gives us the negative x. And we have the positive 1 times the negative 1. That'll give us the negative 1 here. And so even though this didn't look very separable from first glance, it actually is. So now we can continue with the problem. Right. So we're going to multiply by dx on both sides of the differential equation, and then we're going to divide by y minus 1 on both sides. So you end up with 1 over y minus 1 dy is equal to x plus 1 dx. And again, as usual, we're going to integrate indefinite integral of 1 over y minus 1 dy equals indefinite integral of x plus 1 plus dx. All right, the indefinite integral of 1 over y minus 1, well, that's going to be natural log absolute value of y minus 1. And that's going to equal x squared over 2 plus x plus the constant of integration. All right, so now we'd like to get rid of this natural log, and we can. So we're going to do exponential of natural log absolute value y minus 1 equals exponential of x squared over 2 plus x plus c. All right, we like to simplify both these if we can. So e to the natural log, we can drop those, they cancel. So we just get absolute value y minus 1 equals, I want to split this up, so I have e to the x squared over 2 plus x times e to the c, right? But that's the same as e to the x squared over 2 plus x times c. So I can just write that as c e to the x squared over 2 plus x. And down here, we still have our absolute value y minus 1. So what I want to do, though, is I can also get rid of that. So right, it ends up being, let's see, positive is y if y is greater than 1, or it's negative, this quantity, if y is less than 1, and it's 0 if y is 1. So we're just going to write plus or minus y minus 1 equals c e to the x squared over 2 plus x. And again, we can absorb this plus minus into that constant of integration. So we're just going to have y minus 1 equals plus or minus c e to the x squared over 2 plus x. And then that plus minus, we're just going to absorb into the constant, because all we care about at the end is that we have a constant. We don't care about all these steps in between. So right, e to the x squared over 2 plus x. Then the very last thing is we're just going to add 1. So we get y of x equals c e to the x squared over 2 plus x plus 1. That was a fun bit of algebra. And right, this is a trick that sometimes you'll get. Another common one, somewhat common, is trig identities sometimes can make a differential equation that doesn't look separable. By combining or expanding terms, you can sometimes make it into a separable differential equation. But in general, that's how these go.